Here in this question, in photoelectric effect, the work function of the metal is 3.5 electron volt. The emitted electrons can be stopped by applying the potential of minus 1.2 volt. Then which of the following is correct? So first of all, I have to start with what is the given parameters. So given the work function is phi naught 3.5 electron volt, and the second one is the emitted electrons can be stopped. The emitted electrons can be stopped by applying the potential of minus 1.2 volt. So that is nothing but a negative potential which can apply to stop the photoelectric effect. That is nothing but stopping potential. That is stopping potential equals to 1.2 volt. This is the given data. But once go through the options, he asked that energy of incident photon and the first two options, and the option C is if higher the frequency of photon is used, the photoelectric current will be rise. The higher the frequency of photon is used. I think you are very familiar about that. The photoelectric current does not depend on the frequency of incident photon. This is a very, very important point. Photoelectric current does not depend on frequency of incident photon. So then option C is wrong. Then what about option D? When the energy of photon is 3.5, the energy of incident photon is 3.5, the photoelectric current will be maximum. Once look at this value 3.5, but once look at the question, 3.5 is the work function. 3.5 is the work function. So here the energy of photon which is equals to work function, then the photoelectrons does not have kinetic energy. So if the question is how can you know that? Just go to the equation of photoelectric effect. Equation of photoelectric effect. Equation of photoelectric effect, then E is equals to, E stands for energy of incident photon. Now this is a phi naught plus Ke max. Once look at this fourth option, the energy of incident photon is 3.5. As per the question, 3.5 is the work function. Now this is a 3.5 electron volt, this is also 3.5 electron volt, and the Ke maximum. So we both will be cancelled. Now the Ke maxima equals to 0. That means when the electrons are emitted in the photoelectric emission, this does not have kinetic energy. Does not have kinetic energy means there does not flows. The does not flow means there is no flow of charge, in the sense there is no current. So then option D also wrong. So we have to check it, option A and option B. Once go through this equation is. So here the Ke max, then when you apply the negative potential, the electron completely loses its kinetic energy in the form of electrostatic potential energy. So then Ke max can be written as electrostatic potential energy and applied of negative potential, that's EV naught. Now the equation rewritten as, then E is equals to phi naught plus EV naught. So E stands for energy of incident photon. Now from this equation I will write then E is equals to phi naught given as 3.5 electron volt and 3.5 electron volt plus EV naught. V naught is 1.2. This EV naught becomes, that is a 1.2 electron volt. Then our answer is 4.6. 0.7 electron volt. This is the answer. Now option A is correct. Now move to the second question. He gave that the graph between stopping potential versus frequency. He asked the question is, find the threshold wavelength of the metal. So what is threshold wavelength? We are very familiar about that. Threshold wavelength is nothing but the maximum wavelength which can causes photoelectric effect. Now, then how can it the threshold wavelength expressed in terms of work function? You know that phi naught equals to h nu naught. Nu naught is the threshold frequency. Nu naught is the threshold frequency. It can be written as hc by lambda naught. Here the lambda naught is the threshold wavelength. Threshold wavelength. Here this is an electromagnetic radiation, so we can write nu naught is equal to c by lambda naught. Nu naught equals to c by lambda naught. This is the c is the speed of the light in vacuum, and the nu naught is the frequency, and lambda naught is the wavelength. This is that. Now come to the graph. He gave the graph between stopping potential and the frequency. From this graph, how can you find the lambda naught? So you can easily understood these relations if you know the work function. This is called as a work function. This is called as a work function of the metal. If you know the work function, automatically you can find the threshold wavelength. So now I want to know, check it, how can you find the work function by using the graph. So here the graph is between the stopping potential and the frequency. So now again I move to the photoelectric effect equation. Photoelectric effect equation of photoelectric effect. That is E equals to phi naught plus Ke max. This can be rewritten as E is equals to phi naught plus EV naught. Then E is equal to energy of incident photon. E is equals to energy of incident photon. Then energy of incident photon, E is equals to energy of incident photon, that is hc by lambda, or otherwise h nu. This is energy of incident photon. This is energy of incident photon. Energy of incident photon. Now the KEM is equal to KE maxima. EV naught is equals to equivalent energy of KE maxima, and the V naught is stopping potential. V naught is stopping potential. E naught is stopping potential. So once observe the curve, he gave from the just x intercept, which is equal to the frequency of 5 into 10 power 14 hertz, x intercept. So once you have to rewrite this equation in which is in the form of any equation which represents this graph. Then I am writing here that I bring to this EV naught this side. Then E is equals to h nu. Now I will rewrite this equation. H nu equals to phi naught plus EV naught. Now the H nu minus EV naught equals to phi naught. H nu minus EV naught equals to phi naught. Now I divide with the phi naught in either sides. Now this equation becomes h nu by phi naught minus ev naught by phi naught equals to 1. Once observe this equation, h nu by phi naught and minus ev naught by phi naught equals to 1. Now I am rewriting this equation nu by phi naught by h plus v naught by minus phi naught by e equals to 1. This is exactly in the same manner of the equation of x by a plus y by b equals to 1. In the equation x by a plus y by b, then a is x-intercept, b is a y-intercept. So x-intercept in the sense the curve where it cuts an x-axis. Now there's from the given curve, x-intercept is 5 into 10 power 14 Hz. For the given curve, given graph, so the x-intercept a equals to 5 into 10 power 14 Hz. Now as per this equation, x-intercept equals to phi naught by h. From this curve, x-intercept is nothing but frequency. Frequency intercept is phi naught by h on x-axis. So we are comparing these two. Phi naught by h equals to 5 into 10 power 14 Hz, 10 power 14 Hz. Then we already know in the beginning phi naught equals to hc by lambda naught into 1 by h equals to 5 into 10 power 14. Then from this we can cancel the h on either sides. We want threshold length lambda naught. Now that from this threshold length lambda naught equals to c by 5 into 10 power 14. That c is the speed of the light in vacuum. The speed c is the speed of the light in vacuum. That's 3 into 10 power 8 meters per second. We are substituted this 3 into 10 power 8 meters per second by 5 into 10 power 14. That is nothing but 0.6 into 10 power minus 6 meter. Once look at this options. In the options he gave the values are in angstroms and meters also. In meters he gave 5 into 10 power 14. That is not our answer. Here we move to the conversion of wavelength in angstroms. So 0.6 into 10 power 6 meters, we have to put it here 0.6 into 10 power minus 6 multiplied with 10 power minus 4 into 10 power plus 4. Why? Because we are very familiar about that 1 angstrom equals to 10 power minus 10 meters. So then 10 power minus 6 into 10 power minus 4 equal 10 power minus 10 angstroms. Then our answer is 6000 angstroms. So the for a given that equation, for a given function, given graph, what is the threshold wavelength equals to 6000 angstrom degrees. So our answer is option B is the right answer. In this question, which of the following graphs represents the variation of maximum kinetic energy of the emitted electrons with the frequency in photoelectric effect correctly. So you ask that the graph between maximum kinetic energy and the frequency. To obtain this graph, we should know about that what is the relation between maximum kinetic energy and frequency. To know the relation between the maximum kinetic energy and frequency, we move to the equation of photoelectric effect. Equation of photoelectric effect. Equation of photoelectric effect. E is equals to phi naught plus Ke max. Here E equals to energy of incident photon. This is equals to h nu or hc by lambda. Here, as per the question, all the graphs are with kinetic energy and the frequency, so we should leave here the energy in the form of h nu only. That's phi naught equals to work function of the metal. Work function of the metal, and the Ke max equals to the maximum energy of emitted electron, the maximum kinetic energy, this maximum kinetic energy of emitted electron in photoelectric effect. Now I will take this equation again to observe this options, which one is right. So just look at here, E is equals to phi naught plus Ke maximum. Now on y axis is Ke maximum and x axis frequency. Now Ke max equals to E minus phi naught. E is nothing but h nu minus phi naught. So now once observe this equation, then the maximum kinetic energy equals to h nu minus phi naught. This is the relation between the maximum kinetic energy and the frequency. Once observe this graph, this in the form of y is equals to mx minus c. Then y equal to mx minus c. Then which graph is represents in the equation y is equal to mx minus c? The slope is positive, y-intercept is negative. Now this is passing to the origin, so this is not the correct answer. Now this is a negative slope. This is also not the correct answer. But here once observe this is y-intercept is positive. This is also right, wrong answer. Now once observe this option D, then y is equal to mx minus c. This equation represent here this x-intercept. Observe here x-intercept frequency at which the kinetic energy is 0. Then this frequency is called as threshold frequency. Now our answer is option D is correct. Thank you.